Okay, so where are we? Uh, we have all our unit tests running. Let's go and just review where the app is at. So let's go ahead and run the application. And remember now it's going to take a little bit longer to start up because running with the database, that takes a little bit longer. Well, cannot load driver? Did I mess up something in the POM file? Oh, yeah, okay. So I was playing around with something about commenting stuff out, and clearly I commented out the PostgreSQL driver itself, so at runtime I couldn't find it. Oh, I've seen this happen where this file didn't get saved, and so IntelliJ didn't actually see that I changed the POM file, so it didn't load up the dependency. And you can see that because I'm looking here at the dependencies in the POM file. You can see that H2 is there, but we don't see the PostgreSQL driver. Let me close it, go here. Let's do a refresh. There it is. So now we see Postgres over here. Let's, third time's the charm, I guess. Oh, come on. Oh, okay. So remember, this all the funny things. So if we go to our application properties, and actually this is a good time to handle this. When we had wanted to deploy it to Heroku, so remember Heroku supplies the database credentials and information in the environment, and using this syntax allows us to get those properties from the environment and pass them along so that Spring Data can use them. Of course, I don't have on my local machine, I don't have these environment variables set. We can see this error right here. Driver claims not to accept JDBC URL, and this is the text. It's a very interesting way of phrasing it, claims not to not accept. Basically, this URL is not a valid Postgres URL, which it's not, because it should have pulled it from an environment variable. So what we want to do is we want to have two different configuration files. So application properties is an externalized configuration, and it's sort of the default file that gets read. What we'd like though is we want two different versions of this. We want one version that'll run on Heroku, and another version that will run locally. The way that we do this in Spring is we can have multiple application properties files with slightly different names. So let's do that. So let's copy this file, and we're going to call this application Heroku properties. And so now we can delete all this stuff that we commented out. I'll leave this here because, so I think what we're going to do is on Heroku, we'll use Postgres, but locally, I think locally we'll just use the H2 driver. We won't use the local Docker Postgres. If we want to, we can create another config file for that. So this is specific to Heroku, right? So it's going to use the properties coming from the environment. This will actually, I think I'll leave this here because then I actually want to take it out, because when we run locally with H2, I think we're just going to want a clean database each time. Since we copied over the Postgres stuff to the Heroku, we can delete this. And we don't need these because this was when we wanted to have the persisted H2 stuff local to a file. We don't need this anymore. Don't think we need the driver. I think it figures out that it's an H2 driver automatically. So in a sense, we really have nothing in the default configuration file. We may have some stuff later if I decide. I'll leave this here because we may decide that we want to persist stuff across H2 instances. Okay, so we now have two configuration files. This one is the default one. So this one gets loaded up first. This one called just application.properties. This one gets loaded up first. And then any more specific properties will get loaded. So now the question might be, well, how does it know to load this Heroku one? So there's a thing in Spring called profiles, and so we can look at the docs here. Let's take a quick look at profiles first, and then we'll look at properties and config. We'll actually see how we can use profiles as annotations in our code. The way we set those profiles is there's a bit of recursion here because you can basically set active profiles in an application properties file, which is weird if you think about it. But if you just have one application properties file that then sets other properties, then that's one way of doing it. The other way to override it is you can set a command line parameter. So there are two ways to do this. There's this way, which is a switch, this dash dash spring profiles active. This property is a switch to the program. This is different from what you might have seen with a -d parameter that sets basically an environment variable for the JVM. And so it's a little confusing that there are two ways of doing this. We can also set the spring profiles active as an environment property. And that's actually what we want to do with Heroku. Hold on, I'm just going to log in here. There's a couple ways we can do this. We can actually configure this line here. So remember I said the -d. So -d is a way of setting a property, but I can also, if you put it after the jar, then anything is a command to the program itself. And then that would be the dash. So basically we can set a config var. I think that'll work. So we can say spring profiles active, and that's going to be Heroku. Okay, this is basically the default, what Heroku calls a proc file. We could have changed the proc file and put the -- spring profiles at the end of basically what's its command line. But I'm going to see if the config var's way works. It should work. Let's go back to our code. All right, so now that we've separated out and split the profiles, let's actually go here. So one of the other nice things about Lombok, the tool that we're using for writing basically getters and setters and constructors and things like that, is it has this SLF for J tag, which basically means it will automatically generate a logger for the current class. Because that's pretty much boilerplate. This is right here is pretty much what you want. You want log, which is an SLF for J logger, and it'll use the current class that it's in. Because what I want to do here, actually, never mind. I'm not gonna log that. I was thinking I'd log like what profile we are, but I think we'll actually see that in Spring's output anyway. All right, so now that we split the application configuration into two, when we run it now, it's going to use these properties, and since it's all commented out, it will use just all the defaults. Since H2 is on our class path, it will choose H2 as the database, just use the in-memory version, and it should all just work. So let's see. So let's look through the logging a bit. So no active profile, falling back to default profile. So by default, the profile is called default. That means it will use, if we could actually have an application-default, but in a sense, application properties gets used as sort of the baseline. Hibernate, Hikari is the connection pool, so remember we saw that yesterday. Hibernate core. So here we see it's using the H2 dialect because it automatically detected that we're using the H2 in-memory database. And then the rest of the stuff is pretty standard. Okay, so if we now go to localhost, we should see our app with no transactions. Great. Let me do my usual loading up of a bunch of transactions. And there we go. That's all good. So today we wanted to work on calculating interest, doing authentication, and looking at seeing how to do SMS text messaging. Calculating interest I'd like to do first. So let's go and figure out what we want from that. Right now, if you look in the data that I imported, you actually see that I have manual entries for the interest calculations. The idea is that it's anywhere from 2% to maybe 2.5% per year, and the interest is credited monthly. So I did it at the beginning of the month. Maybe it should be at the end of the month, but the beginning of the month is from a date calculation standpoint is a lot easier to work with. Having worked on billing systems that have to deal with months and the varying sizes thereof, and what is the last day of the month, can get hard to figure out. The difference, you want to calculate anyway, what was the balance at the end of the month. Technically, we should use the average daily balance or something like that, but I'm just using the balance at the point when the interest is calculated, which is a bit perhaps unfair, but at these levels where the interest amounts are in the less than 20, 30 cents, it's not going to be that much of a problem. Let's look at our task. Configuration for Postgres, local versus Heroku. We did that. Just did that, so yay. Persistence and integration test cleanup. I want to hold off on that. I want to actually get some meaty user story stuff done. So I'm going to consider these two tied together, that we're not fully done with this story until I do the integration test cleanup. So I'm just going to leave those there. So right now, let's look at calculate interest credit. Yes, I'm violating my work in progress limits, but I like to sort of shift back and forth between, it's a little bit of drudge work with the integration test cleanup, even though I know it'll probably only take like 10 minutes, if not less. But I want to get into the calculate interest credit. So what we want is not to have manual transactions that have the interest credit, but to basically calculate it. We'll hard code the initial interest rate. So that's actually something that could put as a property. But basically, we'll sort of hard code that somewhere, that the interest rate, and I'll bump it up to 2.5% since interest rates are going up. So what we want is, on the first of every month, the interest to be calculated. So right, it's going to multiply 2.5% divided by 12, right? Because it's 2.5% per year, so there are 12 months, so we divide it by 12. So whatever the balance is, whatever the current balance is, multiply that by 2.5% divided by 12. And that would be our interest, and then that becomes a deposit. So if we think about what that means, let's see, let's go to this in our domain, count test. What we want is something that every month interest should be deposited into account. This is a placeholder test. It's likely going to be much more specific once we figure out what we want to do. But I always like thinking about this stuff coming from the point of view of what would a test look like. And this is more of the behavior-driven development BDD language, where we have given, when, then. So given an account with $100 when it's the first of the month, let's be precise, when it's day 1 of the month, then deposit $100 times 2.5% divided by 12 into the account. This is straightforward, right? We can just say account equals an account, and right, starts, and then do a deposit for $100. And we'll use our fake transaction repository, and then we can say account, deposit, local date time of 2016-6700. And it starts off with 100, which, remember, since we're scale decimal, is actually 10,000. Initial deposit. So now this is the tricky part. When it's day 1 of the month, there are several different ways we could do this. One is there's some background process that sort of wakes up every month. So sort of like a cron or a scheduled thing, that every month it wakes up and says, is it the first of the month yet? And if it is, then go ahead and calculate the amount of interest to credit, and then deposit it, and then sort of go back to sleep for a month. That's one way of doing it, and I'll probably get to doing it that way. It's a bit of overkill, but there's a scheduler tool called Quartz that Spring has adapted. So in fact, if you look in the Maven project, you'll see it's commented out. Where is it? Here. So basically, I have the Spring Boot Quartz starter that we'll include later when we get there. So it's a bit of overkill, but again, I'm doing this project not just to get the app done, but also to learn things and to try different things out. I haven't used Quartz in a really long time, certainly not in the context of Spring, so that will be interesting. But right now, since I don't want to do that, the other way, and this was an idea from a friend of mine who I was pairing with, is do it on the fly, right? We're calculating the balance on the fly all the time anyway, right? So if we go to account, right, in our balance method, we no longer store it as just some variable. we basically do a stream and sum over all of the amounts to come up with a balance. So that way, what we can do is when balance is called, we can say, hey, is it time to calculate the interest? So, it would be something like, is it the first of the month? And have we sort of not credited interest yet? Right, so if it's the first of the month, we want to tack on an interest deposit. But we want to make sure we don't do that more than once per month. So we'll have to figure that out. And so that's possibly a little tricky. The other thing is since we're going to be figuring out stuff around dates, that's going to mean we're going to have to inject something that will provide dates for us. Because if we don't do that, there's no way to do it from a test point of view. And we'll see that since we're going to start with tests, we're going to see that we're going to want to inject some way of figuring out what the date is. So let's go back to our test. And so here it's, we'll have to figure out, create some mock clock and set it to first of month. And we're not doing the deposit. What our then is, this amount should be credited into the account. So we start with an account with $100. We're going to have to do some stuff here. And our expectation is we'll assert that our account.balance is equal to, so 100 plus, and now this is going to get tricky. We're going to have to think about what kind of rounding is going to happen. So for $100, that's pretty straightforward. So it's 100 times 0.025, and then we divide that by 12, and that's what it should be. I don't know what that is. Somebody else can do the math. All right, somebody else will be me. So that's going to be 20.83 in cents. So is that 20 cents or 21 cents? I am not sure. So we should be sure about that. So let's go here. So remember that this is in cents, and so we'll need to basically divide again by 100. So we'll divide again by 100 to get that. And so that's basically, so the question is this going to be 20 cents or 21 cents? Rounding up would be nice. So let's say it's 21 cents, and 21 cents is basically 2100. So let's put a note here that rounding up 20.8333 to 21 cents. Okay, so clearly this will fail because we have nothing that does this part, but let's run it anyway. And I forgot to set my Pomodoro timer again. I should totally make an app for that. Okay, so it failed as expected. The downside of being able to write web apps is any idea that pops into your head is like, oh, I could write a web app for that. And that's something that happens to me often, hence this app. Okay, so when it's we're going to have to write a test also that when it's not the first of the month, the balance shouldn't change. I think we sort of already have a test for that because we have our deposit test. So one of the things we're going to have to do is make sure for these tests it is not the first of the month. Because if it is the first of the month, so we'll have to make sure that these other tests, that the fake, whatever fake clock we use, is going to be one that it's not the first of the month unless we're doing this interest stuff. And I realize this should actually be in a separate class. So let's actually move this to, this is really interest credit test. So delete this one, go back to account test, and delete this. Okay. So let's put a reminder for that. Let me go to my to-do. Why did it do that? Let me try that again. To-do. So just because I keep doing this and keep going to the wrong thing, there are two sides to this recent files pop-up in IntelliJ. The one on the left is basically one of the tool windows. The one on the right are the actual files. And I keep jumping to the to-do on the left when it's actually I want to go to tasks. So maybe I shouldn't be searching for to-do anymore. I should just search for tasks. There we go. So I need to put a reminder to look at these. Ensure the blah blah transaction. Okay, so we actually did that, so we can go ahead and delete that. This is probably not a good idea because now I have tasks in two places here and in the Trello, but let's put this here anyway. So the date supplier needs to never return first of the month for tests unless the test is actually wanting to check for interest credit. Okay. Grab my coffee. Pomodoro timer. I said that, didn't I? Where's my Pomodoro timer? Is there a Pomodoro plugin for IntelliJ? So there's the joke, and it's not really much of a joke, is that I don't know how people have phrased it, but it's something like all editors will eventually, or actually all software, but mainly I think it was focused on editors, will eventually acquire the ability to do email. This is based on Emacs, which eventually did acquire, or not eventually, pretty early on, at least when I was working with Emacs, could do pretty much everything. You could browse the pre-web, whatever, Gophers and things like that, and email. And so I'm surprised IntelliJ doesn't have a plugin for email, although maybe it's just because I haven't looked. So let's go and browse repositories. I'm just curious, email. Has anybody done it? It doesn't look that way. It would not surprise me, though, if somebody did. Okay, but what I am looking for is Pomodoro. Well, hey, there is a plugin for that. Hasn't been updated in a year. Wonder if it still works. So there's this one, there's this really old one, and then there's this one, which hasn't been updated in 3 years. But this one looks pretty popular. Choose a task to be accomplished, start the Pomodoro timer, and let's take a quick look. Oh, whoopsie. That just deployed Firefox, which I had closed before. So let's copy this. Dang it. That's interesting. There was a commit in October, I guess, just to fix the build, but it hasn't really been deployed. What does it look like? Oh, so it's a little timer down there. Okay, well, might try that out. So let's go ahead and install that. What else? Database Navigator. Oh, I'd turn that off because I don't want that. Oh, well, I may as well check for updates. Oh, so that one's updated. What do they fix? It's funny, I'm not even using that plugin. Yeah, let's go ahead and restart. So let's think about what we're doing here. So we're calculating the interest. We want to, if it's the first of the month, we want to have a credit for, sort of have it a just-in-time credit so that when we request the balance and it says it's the first of the month, it does a deposit. So that's a side effect of balance. Not sure how I feel about that. Well, I don't know if you heard that beep, but oh my God, that was loud. That was, I guess, the default beep when the new plugin started. So here it is. Yes, you can go away, and yes. And that's not the window we want anyway. We want KidBank. Okay. Just want to run all the unit tests so I can have that window open. And in the meantime, while it's running those, which will take no time at all, let's, oh, cool. I just click on it and it's timer. All right. Cool. Well, I guess now I don't have to write that app because it's in there for me. That's nice. Okay. A side note on tests, since unit tests run so fast because it's just memory, and basically, even though there's a little bit of overhead of running tests, in general, there's no reason not to be running all the unit tests all the time. I've seen, I fall into this myself, and it's sort of a, not great habit, and I see lots of people do it, not realizing that while you're fixing the current test, you've broken something else. So the whole point of doing this is we want to make sure that the only thing that's failing is what we're expected to fail when we first write the test, and not like other things that we didn't expect to test. So, all right, so all our tests pass except for the one that fails because we're not calculating interest. We could do the simplest thing that possibly works, right? The simplest thing that could possibly work. That's the acronym. Not a great acronym, but it's one I use all the time. So the idea is there's nothing we would, in this test, do here. Setting the mock clock and setting it to the first of the month would actually be something we would need to do because we'd have to somehow get it injected into account. So when we assert that the balance, let's see, today is January 26th, so it definitely will not be triggered if we use the real date. So the only thing we want to do is, let's see. So I could make this test pass by whenever you call the balance, it always credits the interest. So we basically want to do a deposit of local date time.now. And you'll notice that there's one that takes a clock. This will become key. We want to be able to pass in a clock. Why are you all the way over there? From the specified clock. So clock is something that they added, and we can basically. It's funny that they call this this dependency injector. So basically, we can do now, but based on a clock that we give it instead of the default clock, which is this one. Why are you over there? Come back. Come back, window. Come back. Why can't I drag? Oh, that's weird. I can only drag a part of you. So this one obtains it from the system clock. This one, this one gets it. All right, forget it. This one gets it from the clock that we pass in. So we'll do this one for now, no pun intended. But we'll see later on that the clock is something we want to have supplied so that we can have control over it to help with our testing. Okay, so deposit takes the date time, which is now, the amount, which is going to be basically current balance times interest rate per month, something like that. And this is interest credit. So that's what we want the method to look like. In order to calculate the interest, we need the current balance, which we calculate here. So we'll need to pull this into a variable, and we will call it current balance. And so now we can move this above here. We'll see in a second that this isn't going to be correct because we're going to have to add on. We'll have to see how we want to do that. Basically, do we do current balance plus equals the interest rate? Basically the amount of this deposit. So this, and then we'll have to do a stream to recalculate the balance, or do we just add it? All right, let's not get ahead of ourselves. So let's pull this out. This is going to be the interest credit. So I'll keep that comment in here. So this interest rate per month, let's just go ahead and make this a constant. Oops. So we'll call, so this is basically, what did we say? 0.025, right? So that's 2.5% divided by 12. And yeah, we're going to have some, this is where we get into fun decimal stuff. So let's make this a constant. And this is interest rate per month. So how do we want to calculate this? If we promote this to double, so we can cast this back to int. That might be fine. What I don't know yet is about rounding. I'm guessing that we probably want to throw some big decimal stuff in here because it can handle different kinds of rounding that we need. But this might be good enough. So we've calculated the interest and we've deposited it. And so now we need to basically say current balance plus interest credit. So let's start out with that. I'm a little unhappy with this. Eventually we're going to want to pull this out into a method. And then this will be interesting. But let's do that for now. So we've gathered the current balance, right? Basically summed through all the transactions, calculated the interest, made a deposit, and then return. Now, obviously, every time we call balance, this is going to happen, but so it's possible that a whole bunch of tests are going to fail. In fact, lots of tests should fail. What I'm interested in is this one. I think my expectation was wrong. So working in pennies is a little difficult. It's not 2,100 because that would be $21. It's actually that. So so I was expecting rounding up. It looks like it rounded down. So let's just run this test because we know we're breaking a lot of others and we'll come back and fix those. But let's focus now on this test. Okay, so we're close. Let's take a break. And even though the Pomodoro timer, we haven't taken a break yet, it's coming up on the hour. So I'm going to take a 5-minute break. And when we come back, we'll see how we want to handle the rounding. Okay, so before the break, we were looking at the proper calculation for rounding. I realized I was off. And so now basically we calculated the interest rate to be 20.833 repeating decimal cents. We might want to round that up to 21 cents, but currently it's clearly just completely deleting, just dropping the decimal. Part of me is tempted to figure out how to make it work with rounding up. And so there are a couple of ways we can do it. The old school method of rounding up is what you do is you add you add half a cent, and then when you drop the decimals, you get the right thing, right? That's how you can round up. Right, so that would mean you start with 28 and a repeating decimal, you add half a cent, right? These are cents, and you get 21 point, so what is that? 33, repeating decimal, and then you drop this and you get 21. So we could do sort of a simple rounding, which from a performance memory standpoint is going to be way better than creating a big decimal, having it do the rounding, and then converting the big decimal back to an int. That's a bunch of objects that we really don't need. So let's pull this into a method. So calculate interest. And so what we can do is add 0.5. Right, these are cents, so that's cool. Interest, credit, rounding up. Probably more information than you want, but there are various methods of rounding. There's half rounding up and half rounding down. Because if you think about it, if you always round up, no, all right, you can look it up. There's interesting stuff about you only round up even numbers versus odd numbers. Anyway, so but we're going to always round up because this is Kid Bank. Okay, so now if we run the single test, that one should pass. Great. I don't feel like I could test this method. I don't feel like that's necessary. This is math, and it's just will. There's no decision here. It's just math, and the math works. So this test now passes. Of course, now if we go ahead and run all the other tests, whoops, all those other ones are failing because every time you ask for the balance, it's going to credit interest, and that's not what we want, right? Well, that might be what my son wants, but that's not what I want. So we need to now figure out is only do this when it's the first day of the month. So that means who is responsible for figuring that out. So there's this interest crediting thing that we're doing on the fly when we ask for the balance. So right now that's an account. So that means account has to have knowledge of basically this interest, this credit part, the calculate interest, and then the credit interest. Actually, let me do that. So let me pull this out into. No, before I do that, let's walk through this. So I want this to happen only if it's the first of the month. And so let's just handle that part. So we'll handle that, and then we'll have to handle the situation of when the balance, when it's basically the credit, these basically want to account for if the interest credit has been credited for that month already. Haven't really thought much how I'm going to do that, but we'll get there. But let's first make sure that the interest is credited only on the first of the month. So that way we can make sure that all the other tests, we want to get all our tests passing. Well, so what we're going to need is we're going to need some clock supplier. So let's take a look at that clock that clock method. So here, remember, we did now, but now there was one that took a clock. So that one. Come on. And so this clock so what we're going to do is we're basically going to do something like this, right? So we're going to inject a clock, and then that clock is going to return a fixed thing. So one of the things in tests is stuff that can change that's not part of what you're actually doing, of the code you're writing. You want to be able to mock so you have control over it, right? So you want to fix things so that the stuff you're testing is the stuff that you're worried about, and that everything else is a known value, right? Because tests are basically predictions, and you need to be able to predict precisely and always whether something happens. So we can't depend on what date it actually is, or we don't want to depend on, did you make sure to set the server so that its date is whatever. You want that completely controlled by the test itself. So the question is, where do we get a clock? So it looks like clock has a bunch of different default implementations. What's nice is there's this fixed one that basically always returns the same instant. So instant is a technical term for a current, basically a point in time. And so this is what we're going to use in our test. So we're going to use a fixed clock in our test. However, so what we need is we need that to be injected. So we're going to go ahead and create a field called clock. And now the question is, where does that come from? Well, just like we had the transaction repository injected, we're going to have the clock injected. And we can make this final, which means we'll have to have our constructor do it. So we'll add a constructor parameter. Actually, we don't have, well, if we don't make it, we can initialize in the constructor. So one possibility is we add a constructor parameter, which means everywhere a count is instantiated, it has to be, a clock has to be passed in. For normal running circumstances, though, we don't need to get a clock injected. We just can grab the actual system clock. Right, so if we initialize in constructor, we just say clock equals clock dot system default zone. Right, I think that's actually what, come on, drag over. So I'm not sure if I need this one or the system UTC. I'm pretty sure I want system default zone. So the way we can check is if we do like datetime, local datetime.now, what does it do? Okay, so it basically does now clock.system default zone. So we know that when we do now, and we use the system default zone, that is the real system time, and that's what we want to use. Good. So that means by default, this will work. We will see no changes. This is, now that we're using clock here, it's doing exactly the same thing. And so for normal circumstances, that's what we want. What we do want, though, is an overloaded constructor that can also take a clock. So that way we can set it specifically for tests that need to adjust the clock. So let's go ahead and generate a constructor that has both a repository and a clock. And so now we can use this one in our test. So let's go back to our interest credit test. And so right now it's using the one with the default system clock, but we can now say clock fixed. Oops, where'd my cursor go? Instant. Instant from I think so this takes a temporal accessor, which I believe local date time will give us. So if we say local date time of and we give it any year, and we'll do February 1st, that works, I think. Oops. What happened here? So hold on, let me pull this out because I'm getting lost with all these parentheses. So actually, let's move this comment up here, and we'll create a clock. Clock equals instant from, oh, it needs a zone ID. Blah. Is there another instant that we can use? So from, what other froms can we use? Temporal accessor. I'm confused here. Oh, fixed is complaining. So fixed, oh, so fixed is the one that needs the zone ID. Okay. Got it. Okay, so our instant is correct. So let me pull this out. And this is Feb 1 of 2017. Okay. Really, is there no other option? I don't really care about fixed instant zone. I don't want the system clock. What does tick minutes do? Oh, that's interesting. If I only want the minutes to change, so it's still paying attention to the actual clock. Ah, that's interesting, but not helpful. We don't want an offset clock. System. All right. Well, then we can just say zone ID system default. That should be fine. Okay, so now we can pass in the clock. And nothing should change because we haven't changed anything in the code. Unable to obtain instant from temporal accessor? But local date time implements that. Why can't you get the instance? Let's see. I can use date to instant, but that's not what I want. Oh, I guess I want a zoned date time. Or maybe just to instant. Yeah, so local date time doesn't, we need the zone offset. So if I do, instead of a local date time, a zoned date time, and so this is going to have some more parameters, the zone ID. Dates are hard. Now what? Let's see, are there other methods that we can do here? Whoops. What is it actually doing? So we can do from, we can also do now, we can also do now clock. That's not what we want. Oh heck, can we just parse a date? Let's just do that. That's just way easier. All right. So we'll just do that. Sure, I could figure it out, but this seems way easier. What's wrong? Of? Oh, parse. So we want, what did we say, of 2017, February 1. Let's just do sort of noon. Yeah, my concern is that will it convert this system, the zone ID system, so this is basically UTC time, and if the time offset is such that the current system's default zone would be sufficiently off that it would change the date, that would be kind of bad. All right, so this is a bit risky. Let's not do that. Let's actually go back to the of. So of, sorry, from boy, I'm telling you, this got to be an easier way. Create an instance from local date time with time zone. Yeah, so I mean that's what we're doing. We're basically creating a local date time and then creating an instant based on that, based on our current zone ID. This is pretty much what we're going to do. Okay, so we have a local date time. No, not advice local. Local date time of, and we said 2017. I'm glad I named that variable well. So 2017, February 1st. We don't care about that part. And then we want to convert this to an instant, but we need a zone offset, and so that's going to be zone ID system default. Doesn't like that. Zone offset, oh, come on. See, I should be able to pass in a zone ID and it should figure it out, but okay, fine. You're going to be that way, so then system default dot, what is the default? We want the zone offset. Okay, so it's clearly not to instant, it's at zone. There's no way I would have known that. Oh my god, date time stuff is so hard. Okay, so we've got an instant for February 1st, and now we have a clock based on that instant. Yeah, time zones suck when you're programming. I love the fact that they make sense. Like, can't have one time around the world, otherwise that's weird. But boy, this all right. So this stuff we'll probably want to put in some kind of test utility class if we find we're going to do it a lot. Okay, so that took a while to establish the fact that we've now set a fixed clock for February 1st. In fact, I'm going to name this clock. Not all occurrences. Clock. Uh, 2017-0201. Boom. Okay. We've got a clock of the first of a month. And again, I don't think that actually changed anything, but at least we've got our test properly set up. Null pointer exception. Null pointer exception. Oh, okay. I think that's okay. So right now we're basically when the deposit happens, the deposit causes an add new transaction. That's interesting. Add new transaction doesn't add all of the existing transactions. The problem is oh, okay. So when I made that change the other day, yeah, so right now transactions is null because here we were implementing it as the transactions to load because we load it from the repository. But otherwise I need to actually set it to, so this dot transaction, transactions equals immutable set of, yeah. Not happy with this. I want to clean up this piece of code because it was a bit hard for me to see what it was doing because this line got in the way. I'm going to actually inline this. Oops. Inline. And now I can do a bit more of the find all build. Yeah, that's better. Okay. And I don't need the, I guess I do need this for that. So yeah, so what happened was transactions was null because I'm now calling this constructor and it wasn't setting it. So now we set it to empty. And so at least this test will fail, but not because of a null pointer exception. Awesome. And in fact, actually, the interest credit test now passes again because it passed before. And so now we basically have 7 tests failing because we're always crediting interest, which we want to stop doing. So now we want to check, is it the first of the month? And so we're going to grab the clock to do that. Now, I could just add an if statement to surround this part. But I sort of have a rule of thumb that I follow is the second I want to do some kind of if statement, I may as well put that into a method. So let's move this into a method. Oops, not that much. So credit interest. Now the naming is a bit weird because we're not always crediting interest. Because you might want to say credit interest as needed. That's kind of weird. I'm not going to come up with a perfect name right now. All right, I'm going to put that. I'm not happy with the name, but nothing better is coming to me. If anybody wants to suggest a better name for that, please go ahead. So now we're in an interesting state. Just looking at this code, it's a bit weird. We do a stream to calculate the current balance. Then we go ahead and credit the interest, hand it the balance. We get the interest credit so we can add it back. I kind of want this method to almost go back to mostly what it was before. Like what I really want is to do the credit interest check first and then just return this part. So normally, and then have this calculate the interest. Well, I don't know. Do I want to just pass in the current balance and have it return so does lambda stuff take longer? No. I mean, in general, lambdas internally are going to be the same thing as a for loop. So the question is, does it take longer to do this than to keep track of the balance as a variable that gets adjusted? For the number of transactions I expect this thing to have, which is going to be certainly on the order of hundreds, maybe thousands, you will not notice the difference. The difference will certainly be at the edge when it's communicating to other systems. So I think what I want to do is I kind of want to do credit interest as needed. So actually, so this, well, what I was thinking is like I want to do credit interest as needed. That doesn't take any parameters and it figures out the balance, but it's going to need the balance. So I guess this is sort of the best we can do. I'm a little unhappy with it, but the alternatives seem worse. Because the problem is this really has a side effect of it adds a deposit transaction. Yes, so if you just join, this is basically a web app. It's the KidBank web app, and so there's all web app, and so when it displays the balance, sometimes we'll actually be accessing the balance through other mechanisms, but again, the minute you hit any external part storing in a database, hitting something outside, that's going to overwhelm, from a performance standpoint, anything that I might do here. So credit interest is needed. It's weird because it has a side effect, and it also returns the interest credited, which I really don't like. So I'm going to get rid of it. So if I get rid of it, so let's change this. Oops. So I'm just going to get rid of this. Refactor. Oh, whoops, that's not what I wanted. I wanted to actually change the return type. So I want the return type to be void. Yes, now this is going to be unhappy. That's fine. And so now this is basically that. And so now we need to figure out what the new thing is. And for now, I'm just going to basically rerun the sum over all the transactions. So a question, hey there, Spring Boot, yes, I'm doing Spring Boot. It's pretty much the same as JAX-RS. We'll see. If you look at the code, the main differences is just a lot of the annotations and some of the infrastructure work. Whereas JAX-RS Jersey is an implementation of JAX-RS. You'll need to tie that together with other things. So, for example, Drop Wizard ties it together with configuration and logging. But JAX-RS is one standard. That's sort of the Jakarta, what used to be known as JEE standard. The Spring Boot just uses different annotations, but it's part of then the larger Spring framework. I used to do a lot of JAX-RS stuff as part of the Drop Wizard project, but now I do all my stuff in Spring Boot. All right, so this looks kind of weird because basically we're running through the stream to calculate the balance so we can credit it, maybe. And then we're calculating again, so that way we take into account if a transaction here was created. It seems like we should just get rid of this and calculate this balance. Whoops. And just calculate this and sort of pull this in. So let's do that, because I don't like the way this looks. So now this is just credit interest is needed. We'll remove the parameter, and now put this in here. And so now we're good. We'll see that this is going to be nice, because then once we basically need to do is at the first of the month part. So we're going to wrap basically this entire thing into an if statement. So if it's not the first of the month, we're just going to return. So let's do that. So if what is it? So we want to do clock now. Oops, wrong clock. If clock now, oh, right. It's clock.now with the clock. Sorry, not clock. Local daytime now with a clock is equal to, well, we don't want to check if we actually, so what do we want? We want to get, we don't care about we only care about the day. So we want to get day of month. Hey Valabu, or I'm not sure how you want me to pronounce that. a database I'm using internally for running this locally using the internal embedded H2. I've deployed this onto Heroku where I'm using Postgres. I disagree, and I don't want to get into a debate about GraphQL versus REST. Right now I'm not actually using any REST. I will later, but I don't believe that GraphQL is the be-all and end-all for everything. I think each one has its place. But I don't want to get into the GraphQL versus REST API debate because that's not enjoyable for anybody. So, but you can look at the code. I'll throw in a link to it. So, sorry, I have my chat window on my other computer. And I'm typing this from memory, so I hope the link works. Yeah, so that's the link to the repo, so you can take a look. You'll see that actually I have I'm using Spring Data JPA to do that stuff, and you'll find transaction repository and its implementations for how I'm writing stuff to the database. And check my earlier streams where I work on the database stuff if you want to see how we got there. Okay, so what we want to do is we want to get day of month, right? And if that's 1, then we want to credit interest. This is kind of ugly. So what I like to do is extract this into a method. So basically is first of month, but really that's overly specific as a method name. And so really this is should credit interest, right? Because if it's the first of the month, then that should return true, and we'll see that we'll further refine that with, and have we already done it? So now this is basically if should credit interest, then we'll basically go ahead and do that. So I could wrap the whole thing, but actually want to do that and then return. I don't like this, but yeah, I don't know. I mean, this is sort of a guardish clause. No, I'm gonna reverse it. I'm gonna basically do the whole thing and remove that. And come on, IntelliJ should have just removed that. Okay, so in a sense, this comment now goes here. And so now we have, if we should credit interest, then we go ahead and credit the interest. If not, then this will just return. I think this will make all the tests pass. And all the tests pass. So what's nice is we basically, one of the reasons why I pulled this Boolean expression out into a method is so that way this is much easier to read. Right? So I can just see if should credit interest, do the stuff, and if I want to see the details on what this means, then I can look down here. And so in general, this makes code a lot more readable. I'm still not happy with the name as needed, but I haven't come up with anything better yet. So all our unit tests now pass because the ones that aren't setting the clock explicitly just work. There is, though, the possibility that these tests could be run next week and they will all fail because they are not expecting the interest. So I now need to think about that. And I think I wrote that in my tasks, right? Yeah, so basically our date supplier, which is our clock. So we have our interest credit test where we're explicitly setting the date to the first of a month. And we can rename this first of month. Oh, my Pomodoro went off. Good timing. So on first of month, the interest should be deposited into account. We want to write the corollary where it's on not first of month, no interest should be deposited into account. So I'm going to put this into utility method. What I want to pull out are these three. I don't actually care. Yeah, let's basically create a method. I want a method that's going to take a local date time and convert it to a clock for that date. But if I just refactor this, it's going to just refactor it out with no parameters. So in order to prepare for that, I want to pull out the part that I want to be able to change. So that's this. So I'll pull this out into a variable, which is Feb1 Feb1 of 2017 date time. I realize this variable has an uppercase letter at the beginning. That's not good. Okay. Feb1 of 2017, and this is the instant. And so let's, so now that I've pulled the part I want to change out, I can pull this into a method, which is create fixed clock for or on, and then we'll pass in the local date time, and then we can inline this back. And now I don't need that comment anymore. I don't need that comment anymore. And so now on this one, I can basically so I'm going to have a test where it's clock of 2018 05 or actually let's do February 28th just for the heck of it. We'll create a fixed clock on local date time of 2018 to 28, 0, 0. I don't know, if I'm going to create a method here, then you know what? Let's do this. Let's actually refactor this. So because what I want is actually a method that just takes year, month, day. Because none of these I'm using time. So int year, int month, and int day. And then this becomes a local variable. I don't know why I think it's an instant. It's actually a local date time. And this is local date time of the year, month, day, day, and then 0, 0. Actually, can generify these method names. Instant. Okay, so now I have a much easier to work with create fixed clock method that now just takes the parts that we need. We might pull this out into a utility test class. So now I can just do this, and I don't need those pesky zeros anymore. And now I want to create an account that takes a fake account transaction repository and takes our clock, and we'll hold on to that. We'll go ahead and deposit already in a new Pomodoro. Should have taken a break. Well, I'll take a break after I get this test pass. And then actually going to probably call it an episode. So this thing I actually want to extract into a method. Local date time of okay, much better. So let me move, whoops. Let's move these down. Okay, so I was getting tired of constantly passing in 0 zeros anytime I use the local date, so I'm certainly gonna extract that one to there. So local date time at midnight of 2018 to 27. $100, doesn't really matter. Initial deposit. So now we want to assert that when we do account balance, it's still equal to our original deposit amount. So let's just run these two tests. And those both pass, so that's good. So we will have to fix where when we run all tests that the clock that's used is something that basically is a fixed date that is not on the first. I'm going to leave that for next time. So it didn't get as far as I'd hoped. We basically did the calculate interest, and we're actually not even fully done with the calculating of interest, because right now we're calculating the interest on the first of the month. Oh, that reminds me. So I want to test where if I ask for the balance twice on the first of the month, the interest should only be credited once. So let's do that. And then we'll call it a day with a failing test so we know where to pick up next time. On first of month and interest already credited. On first of month, interest should only be deposited once. So it'll be the same setup as this one. But then we basically don't want to assert, we basically want to do just account.balance to force the balance thing to be triggered. We don't care about the value, so when account balance is requested, this is then when we ask for it again, it should still have interest credited only once. So this one will fail, or it should fail. It should be 1,042. Wow. That's interesting. I would have expected it to be 10,042, in other words, $100.42, because it would have credited the interest twice. Really? So this is one of the great things about TDD is that my expectation is broken here. I expected, because we're on the first, so interest should have been credited. Oh. Okay. So this is interesting. So I asked for the balance. It did credit interest as needed. If should interest credit is basically if the day of the month is 1. So it should have done a deposit. There should have been 2. Well, okay, so the other thing we can check is the number of transactions. We should expect that that there's only 2 transactions. So assert that account.transactions has size of 2, right? Because basically the initial deposit plus the interest credit. Let's just run this test. Huh. I am surprised. Curious what those transactions are. So here's account, here are the transactions, there are 2 of them. We've got the initial deposit and the interest credit. But why aren't there 2 interest credits? We call balance twice. That's unexpected. All right, so let's figure out what's going on here. Let's go ahead and look at balance again. So here we call balance. It calls credit interest as needed, which then figures out should it credit interest. Right now the only thing that matters is if the clock's day of month is 1. If it is, it grabs the current balance, calculates the interest, and does a deposit with that interest. And this should have happened every time because it's always day of month 1. All right, so let's okay, so this is the first time through because we are here. Right, we're here, we're calculating the balance, we're doing this, we're figuring out credit, if it should credit the interest. We see that the fixed clock, so this should return true, and we should drop down to here. There's currently 1 transaction, so it's going to map it to int and sum, and our basically our current balance is 10,000 cents. Our interest credit is 21. We do a deposit, we come back here. Now it's a size of 2. We sum it up, and we're basically going to return nothing, it gets thrown away. So now, when we go here, we go to credit interest as needed, should credit the interest. So we're here, size of 2, sum it up, do that, do that. We do another deposit. But this deposit, oh, that's interesting. Okay, so even though we did a deposit, one thing that we've done is because we're using a mutable set, those 2 transactions are exactly equal. Oh, wow. That's bad. This wouldn't happen with a real database because they would get different IDs assigned. That's interesting. So this is failing because we're storing all our transactions in a mutable set, because the idea is that you should not have duplicate transactions. But the problem is that if we look at transaction, we see that we're using Lombok to generate the equals and hash code, and it's basically using these basically 5 variables, but ID is always null because we're not using a database, so this isn't getting generated. So our fake repository, which is what's holding on to all the transactions, so let's go back a second. So here, so what's happening is we're doing a deposit. So deposit creates a transaction, does add new transaction. And the first thing that add new transaction does is save it. This save should have assigned an ID. And normally when we're running it, we're using a database, it will get an ID assigned. And that's why we take this returned one, and that's the one we add. And if we want to be more precise about it, we can say saved transaction, and this is transaction, to really show the difference between the one that came in, which is the new transaction, and the one that we're saving that now has an ID. And this is actually interesting because this is showing the problems with fakes, which are a type of mock. And if your mocks don't truly emulate the behavior that's important, you can get tests that fail, whereas in runtime this would actually work. That's the better scenario than the opposite, which is your tests work and at runtime it fails. So let's go to our fake transaction repository. When we do a save and we want to do an add, let's see. Transaction dot set ID. Okay, yeah, so what we want to do is we want to set the ID when we save it. If it's not already set, I don't think that'll ever happen, but we should check that anyway. Let's do that. So if the transaction get ID is null, then we'll set the transaction. And we'll need some long sequence ID generator. So we need something that generates IDs. A perfect example of this is simply a long. Could do that and just increment it. Could use an atomic long to make sure that we don't have and we'll start at 0. And so then ID generator, we can basically do get an increment. So the nice thing about this is that even though in our tests we may never have to worry about concurrency, this way we're protected against it. So that way we don't have 2 things that get the same ID assigned. Okay, let's stop this and let's run, let's just run the interest credit test. Okay, now we get what we expected. 142. This would have already been violated. There's probably 3 transactions because now it's actually adding new transactions. Okay, let me run all the tests. I expect only this one to fail, and if that's true, then I think we can call it a day. So that one fails. What's the other one that's failing? Count transaction. Deposit should result in 1. Oh, okay. So now that I signed an ID, my fake is assuming that they're IDs. So let's go and fix that one. So this is our, whoops. This is, whoops. So I'll pull this out into expected transaction. So our expected transaction, we need to set its ID to match so that it's going to be 0, 0L, because it's a long. Okay. Now I expect just the one test to fail. And it does. Okay, great. All right. So that's it for this episode. In the next episode, we will handle the situation where to basically fix this broken test. Because what we want to do is we want to make sure that we only credit the interest, not just only on the first, but then only do it once on the first. So we'll have to figure out some way of handling that. And that's going to be some kind of state, perhaps. We could look through the account transactions, see if we already have one like it. That might be the easiest thing we could do. We can try that. And so we'll continue that next time. The stuff that we didn't get to, so we only got through calculate interest. Next time we'll do authentication and the SMS text messaging of the balance so that my son can check his balance without having to log into anything. And there's also the tasks that we need to finish up. So there's this one. Actually, we did that one. So we can call that one done. So we're almost done with the calculate interest credit. We need to handle the situation that I just mentioned, and then we need to do some cleanup on the persistence integration tests, because right now the integration tests are broken, so we'll need to fix that. Then we'll go on to request balance, and I've got authentication here somewhere. I've got multi-tenant, but I'm not ready to do that yet. Request balance. So we'll just do simple authentication, and we'll put that one up for next time. Okay. Thanks for watching. Feel free. So I put here in the chat, I have the reference to the code base. I'm going to push, even though there's a failing test, I'm going to push it anyway because we're at a stopping point. And the failing test will remind us what we need to do next. If you have any comments, you can open up an issue. I'm also happy to receive email. I don't really expect to get spam via this mechanism. So you can go to my website, tedmyoung.com, and you can send me an email at ted@tedmyoung.com. I'm going to start adding some blogs here. You can also head over to my YouTube channel. Subscribe if you haven't. I'm finishing off the other episodes that I've done. I'm about 5 behind, and I'll put them here, and you can comment there. All right, thanks a lot, everyone. I'll see you next time.